with me and not each other, please. Okay, the first thing, guys, those first two questions on mean, median, mode, and range, I go into how to get them there. I just want to bring your some attention here real quick. You can watch, this will be the first video on the series. First video will cover these two problems right here. Make sure you know how to find the interquartile range, even though it doesn't ask for it. It asks for the range. The range would be 20 minus 3 is 17. But I also went ahead and talked about the interquartile range. Watch that video and then watch the the first period video to get how you do those problems. I would try to make sure you do. But guys, it turns out it's pretty good for you guys because this is a question, again, guys, right here. I'm looking at the midterm right here. This is the midterm. It's 25, 26, 28 questions. And guys, on those 28 questions, this idea right here is probably more places than any question. Okay? It says, graph each set of data. Which kind of model best describes this data? Guys, there's three types of models that we've talked about. We've talked about an exponential. Let's talk about an exponential model, which has a common ratio. It has a common ratio. We talked about a linear model, and a linear model has a common, anybody? Difference. There's a common difference. And we talked about a quadratic model, which has a second difference. So guys, what you want to do for each of these problems is you have to look at the values and see how they're changing. So in this problem, somebody with the calculator, tell me what 0.16 divided by 100 is. Isn't that 0.16 divided by 100 is... Oh, wait a minute now. Look, these points aren't in order here. This is -1, -2, -3. So the first thing I would need is to make sure I had my points in order. So I couldn't take this 0.16 and divide it by 100 because it's in the wrong place. Guys, the t-chart would have 0.16 first. Then it would have 0.08. Then it would have 4. Then it would have 20. Then it would have 100. Okay, and so that's x is -3, -2, -1. Here's 0, and then there's 1. And so you look to see if it has a common ratio, a common difference, or a second difference. Again, what's 100 divided by 20? Oh, no. Guys, you couldn't have answered this question without doing this concept. So 20 divided by 4. 4 divided by 0.08. Guys, if you don't know what 4 divided by 0.08 is, guys, 4 divided by 0.08 is 8/100. That doesn't give us the same thing, does it? Does that give us the 5?
I got 50.
I got that from
50?
Yeah.
Oh, I'm sorry. Look, it's 0.8. I wrote it wrong. There's our 5. There's our 5. And then so, again, I have a common ratio. Since it's a common ratio, this is an exponential. It's an exponential model. Okay? Again, the things have to be in order. 0, 1, 2, 3, 4. 3, 9, 11, 9, 3. Okay? Is there a 3 minus 9 is what?
Negative.
I said 3 minus 9 is -6.
9 minus 11. 11 minus 9.
2.
9 minus 3.
0. 6.
Okay, look, this doesn't have a first difference. Negative 6. Negative 6 minus negative 2 is 8. Negative 8 minus negative 2 is 4. Oh, I'm sorry. As I got to do my math right. Negative 6 minus a negative 2. Negative 6 minus a negative 2 is negative 4. Negative 2 minus 2 is negative 4. 2 minus 6 is negative 4. This is called the second difference. The second difference is a quadratic. So number 2 is a quadratic model. Okay, again, make sure the points are in order. The first point has got to be negative 2, 9, then 0, negative 8, then 2, negative 7, 4, negative 6, 6, negative 5, and I believe we probably get, guys, that is a linear model. Not sure, but I want to show you something else. Watch this. Tonight, guys, when you get home and you're working these problems here, I'm on number 3 on section 13.1. Okay, guys, number 3 on section 13.1. Your book has the answers to it in the back of the book. When you go to your electronic book, they're called SA. Okay, so go to SA. This I know happens to be in 13, and it's section 13.1. Okay, you find the section, guys, that corresponds to the problems that you're trying to do. This is from section 13.1. So 13.1, in working problem number 3, I can look at my answers in my online textbook. Okay, this is number 3. Again, wow. See, number 3 says the oven temperature decreases by 50 every 10 minutes. Huh, I thought that was... But that was these problems here. Well, there must have been 1A and 1B. So here's 1A. That was all part of 1A. 1B was quadratic. 1C must be a linear. But that's where your answers are. Okay, it says look for a pattern to describe which it is. 1, here again they're in order. 1 over 2.5, 2.5 over 3, 3 over... That doesn't give me the same thing. So again, you want to try something else. 1 minus 2.5 is 1.5. 2.5 minus 3 is 0.5. 3 minus that is 0.5. Is 1.5. Do the second difference. This number 4 is quadratic, guys. That's how you find. Look, take this. 7.6 minus this. 5.37 minus 3.7. It's the same thing over and over and over. When you get the same number over and over and over, it's linear. That's called the common difference. As you take this, the y coordinate, and subtract the next y, once you get them in order. And so that's how you do that section. Specific question? Right? Same thing here. Again, it says graph each set of data, which kind. When you graph the data, negative 3, negative 5, negative 2, negative 1, 0, 1, 2, 3, it's in the correct order. 7 minus 0. 7 minus 0 is 7. 0 minus 5 is negative 5. Negative 5 minus 8 is negative 3. Negative 8 over negative 9. Negative 9 minus... Look, it doesn't have a common ratio. Nice. So which kind of model best describes this data? Because I don't know what it looks like right here. So negative 3, negative 5 is down here. Negative 2, negative 8 is down here. Negative 1, negative 9. Look at it going right there. 0, negative 8. Now it's going back up over here. So 1, negative 5. What's it doing? 2, 0. What's it making? A parabola. So what should happen here, guys, what should happen when we do 7 minus 0 Okay, 7 minus 0 gives me 7. 0 minus negative 5 gives me 5. Negative 5 minus 8 gives me 3. Negative 8 minus negative 9 gives me 1. So there's the pattern I'm looking for. Again, negative 8 minus negative 5 is negative 3. And so I see that these don't have a first dip. Every time it changed, guys. When I did the math wrong, it didn't work out. Guys, this is going to happen, though, when you do these, and you'll get a common, I'm sorry, you'll get a second difference when you have a quadratic model. If it's the same the first time, it's a linear model. If there's not a common difference, but instead a common ratio, it's a common ratio that it's exponentially. 8.1 over 2.7, 2.7 over 0.9, 0.9 over 0.1. Guys, take your calculator, put those numbers into your calculator. Find out that 8.1 over 2.7 gives you 3. 2.7 over 9 gives you 3. 0.9 over 0. Gives you 3. Since that's the same number over and over and over again, it's a common ratio, then the model that best describes the data is a
quadratic
exponential. This one's quadratic. Second difference is quadratic.
So for the linear one, you talk about for this first row, if that was the same numbers, like meaning like the 4, 2,
7, 5, 3, 1, 2. This number. When you find the common difference. When I say, what's 5 minus 4?
5 minus 4, then
What's 4 minus 3?
1.
What's 3 minus 2? What's 2 minus 1? What's 1 minus 0? What's 0 minus a negative 1? What's 0 minus a negative 1? 1. Guys, again, just like the first time I did this one, you can't just do the numbers and be haphazard about it. Because you've got to do the subtraction correct. And you got to make sure that these numbers go down by the same amount every time. Their common difference is 1, because that's the same number over and over and over again. It's a linear model. If it's not the same number over and over and over again, till the second time you do it, it's a quadratic model. If it doesn't do any of that, but yet has a common ratio, 43,200 over 3,600, 36,000 over 300, 30,000 over 2. If that happened to be the same thing, boom, 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 then it's linear. This isn't the same thing, so you gotta try again and subtract it twice or more than one time, and figure out what it is. And it's one of those three. Look, there's these all over your workbook, or all over your book. It's some extra practice. Just take a QR code, point it at that right there, and your phone will take you right to some extra practice. These are in your book, guys. That's online. That's what that's for. If you take a picture of that code right there, it'll take you a QR code reader. QR code reader. Go to App Store, and it doesn't matter which one you have, and take a picture of it. It'll take you there. There's some more practice there. As again, here's the numbers: 3 over 6, 6 over 12, 12 over 24. Every time it gives me a half. Every time. That means that is a common ratio. Common ratio is an exponential model. An exponential model. I would tell you, guys, that also make sure at some time, if you need my help tonight, you get me on rthill3@gmail.com, and then from there, guys, I can answer any question for you, like this right here. As this is, I'll be online. Just say, Coach Hill, what about? As I can use this website right here just to make a little video. Because I can make a real quick video. I'll take a picture of the problem. There we go. I can send that right back to you, and that'll show you how to do the problem. Okay? And it's on, you just email me at rthill3@gmail.com. And I'll help you however I can.